November 8, 1942. The beaches near Oran, Algeria, still smoked from the morning's naval bombardment when Sergeant Frank Morrison of the 16th Infantry Regiment discovered something that would change the war. His squad had overrun a hastily abandoned German observation post on a ridge overlooking the Mediterranean. Among the scattered papers and discarded equipment lay 3 cylindrical tubes, each roughly 5 feet long, with crude wooden shoulder stocks and simple iron sights welded to their frames. Morrison had never seen anything like them. The tubes were open at both ends, fashioned from what looked like ordinary steel pipe. No breech mechanism, no magazine, no obvious way to load ammunition. One tube still had a rocket protruded from its rear opening, a finned projectile about 2 feet long with a bulbous warhead. The sergeant carefully lifted one of the tubes. It weighed perhaps 15 pounds, lighter than his Browning automatic rifle. He could carry this thing all day without strain. The abandoned German position offered clues to the weapon's purpose. Hastily dug firing positions faced downslope toward the beach approaches where American armor would advance. Empty wooden crates nearby bore stenciled markings in English. United States Army Ordnance Department, Rocket Launcher M1, Aberdeen Proving Ground. The implications took a moment to register. These weren't German weapons. They were American bazookas captured during the chaotic first days of Operation Torch, when green American troops had abandoned equipment under fire or left weapons behind during hasty withdrawals. The Germans had grabbed them, studied them, and positioned them to use against the very tanks America had shipped across the Atlantic. Morrison's company commander, Captain James Radford, arrived at the observation post an hour later. His reaction to the captured bazookas would appear in his after-action report filed on November 10th. The enemy clearly understood the value of these weapons better than our own infantry. They had prepared firing positions with careful attention to concealment and overlapping fields of fire. Had we advanced armor up this ridge yesterday as planned, these captured American rockets would have engaged our Shermans from less than 100 yards. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Captain Radford couldn't know was that his discovery represented just one small piece of a much larger intelligence operation already underway. Those 3 bazookas on the Algerian ridge were headed for Germany within 72 hours, aboard a Luftwaffe transport plane flying from captured airfields in Tunisia. They would arrive at Kummersdorf Proving Grounds, south of Berlin, by November 15th, where Wehrmacht weapons experts would begin the most successful reverse engineering program in modern military history. The American M1 bazooka that German forces captured in North Africa represented something genuinely revolutionary in infantry tactics. For the first time in warfare, a single soldier could engage and destroy an armored vehicle without specialized training, without crew support, and without equipment heavier than a rifle. The weapon's development had been rushed, almost improvised, during the desperate spring months of 1942, when America faced the reality that its infantry possessed no answer to German Panzers. Lieutenant Edward Uhl and Colonel Leslie Skinner had created the bazooka in a flash of inspiration at Aberdeen Proving Ground that May. Their breakthrough was recognizing that a rocket didn't need to be fired from a closed tube like conventional artillery. The rocket motor's own exhaust could vent harmlessly behind the shooter if you simply used an open pipe. Within weeks, they had a working prototype. Within months, production facilities across America were manufacturing thousands of the simple steel tubes. The weapon arrived in North Africa with Operation Torch's assault forces in November 1942, but with one catastrophic oversight. General Dwight Eisenhower discovered the night before the landings that none of his troops had received instruction on the new rocket launcher. The bazookas came with ammunition, but without training manuals, without experienced operators, and without any established tactics for employment. American infantry units opened crates on the beaches to find mysterious tubes and strange finned rockets with no clear guidance on how to use them safely. The predictable chaos followed. Some units fired the weapons incorrectly, suffering burns from the rocket's backblast. Others abandoned the unfamiliar equipment during the confusion of combat. German forces, methodically collecting battlefield intelligence as they had throughout the war, recognized the bazooka's significance immediately. Here was a weapon that threatened to fundamentally alter the balance between infantry and armor that had defined Wehrmacht tactical doctrine since Poland in 1939. The captured bazookas underwent their first German examination at a field workshop near Tunis in late November 1942. Oberst Heinrich Marker, a Wehrmacht ordnance officer attached to the 5th Panzer Army, filed a report that still exists in captured German archives. The American weapon represents a conceptual breakthrough in infantry anti-tank capability. The launcher itself is extraordinarily simple, essentially a steel tube with basic sighting equipment and an electrical firing mechanism. Production costs must be minimal. More significantly, the weapon requires no specialized crew training beyond basic rifle marksmanship. Marker's report noted specific technical details. The M1 bazooka fired a 60mm rocket using battery-powered electrical ignition, 2 standard flashlight batteries, D-cells in American nomenclature, provided current to an electrical contact that ignited the rocket motor. The shaped charge warhead could penetrate approximately 3 inches of armor under ideal conditions, sufficient to threaten German Panzer III and Panzer IV tanks from side or rear aspects. The weapon weighed just 13 pounds empty and could be operated by a single soldier, though a 2-man team allowed faster reloading. But Marker also identified critical weaknesses that would need correction in any German adaptation. The battery ignition system represented the most serious vulnerability. Wehrmacht experience on the Eastern Front had proven repeatedly that batteries failed catastrophically in extreme cold. Temperatures below -10 degrees Celsius rendered standard batteries nearly useless. The wooden shoulder stock of the American bazooka contained a small compartment for 4 D-cell batteries, 2 active and 2 spare. But even this redundancy couldn't overcome the fundamental problem of electrochemical cells in winter conditions. German engineers examining the captured weapons in Tunisia also noted that the 60mm warhead was marginal against Soviet T-34 tanks, which featured sloped armor that could defeat smaller-shaped charges. The Wehrmacht already possessed 88mm shaped charge warheads designed for the Raketenpanzerbüchse 43 Püppchen, a wheeled anti-tank rocket launcher that required a 3-man crew and cost 5,730 Reichsmarks to produce. If German engineers could adapt this existing more powerful ammunition to a shoulder-fired tube, they would create a weapon superior to the American original in penetration while maintaining the bazooka's revolutionary portability. The captured bazookas arrived at Kummersdorf Proving Grounds in mid-November 1942, travelling by military transport through occupied France to Germany. Kummersdorf, located approximately 40 kilometers south of Berlin, served as the Wehrmacht's primary weapons testing and development facility. The installation had been expanding since 1933, and by late 1942 it encompassed multiple firing ranges, metallurgy laboratories, and engineering workshops, where Germany's most advanced weapons underwent evaluation. The bazooka evaluation team at Kummersdorf included representatives from Heereswaffenamt, the Army Weapons Office, and technical specialists from German arms manufacturers who would potentially produce any German version. Their task was straightforward: determine whether the captured American weapon concept could be adapted, improved, and manufactured at scale within Germany's existing industrial infrastructure. The testing began in early December 1942. German technicians fired captured American rockets against armor plate samples, carefully documenting penetration depth, accuracy at various ranges, and reliability under different weather conditions. They disassembled the bazookas completely, measuring every component, analyzing the steel composition of the launch tube, and examining the electrical firing circuit. One aspect particularly impressed the German evaluators. The weapon's extreme simplicity meant it could be manufactured using existing machinery without requiring specialized tooling or exotic materials. The launch tube was nothing more than seamless steel tubing of the type already produced for hydraulic systems and industrial applications. A December 15th report from Kummersdorf to Heereswaffenamt headquarters laid out the conclusions. The American bazooka validates a weapon concept that should be adopted immediately for Wehrmacht infantry use. However, direct copying would be insufficient. A German version must incorporate more powerful ammunition, more reliable ignition, and improved sighting equipment. We estimate that development and initial production could commence within 6 months if resources are allocated appropriately. 6 months proved optimistic, but not by much. What followed demonstrated Germany's remarkable capacity for rapid weapons development, even while fighting a multi-front war. The Wehrmacht moved with unusual speed, driven by reports from the Eastern Front where Soviet tank production was overwhelming German anti-tank capabilities. Infantry units desperately needed portable weapons that could engage armor without waiting for specialized anti-tank guns to arrive. The development program received formal authorization in January 1943. Heereswaffenamt assigned the project to a design team led by Dr. Heinrich Langweiler, an engineer who had previously worked on the Pupchen rocket launcher. Langweiler's team faced several interconnected challenges. They needed to scale up the launch tube to accommodate 88mm ammunition, redesign the ignition system to eliminate batteries, improve the sighting system for better accuracy, and accomplish all this while keeping the weapon light enough for infantry use. The ignition system received priority attention. German engineers had experience with magneto-generators, small devices that converted mechanical motion into electrical current. These were already used in Wehrmacht field telephones and some vehicle ignition systems. A magneto-generator could be activated by a simple spring-loaded trigger mechanism, producing sufficient voltage to ignite the rocket motor without any batteries. The design was elegant and robust, functioning reliably in temperature extremes that would render batteries useless. By February 1943, Langweiler's team had working prototypes incorporating the magneto-ignition. The mechanism used a small generator built into the pistol grip. When the operator squeezed the trigger, a spring-loaded striker rotated the generator's armature, producing a pulse of electrical current that traveled through wires to the rocket's ignition element. The system proved remarkably reliable, functioning consistently in temperatures from -40°C to +50°C during environmental testing. Scaling up the tube diameter to 88mm introduced new complications. The larger, heavier rockets generated more recoil force during launch, though the open tube design still absorbed most of the energy through the rear exhaust. More significantly, the 88mm rockets used propellant that continued burning for approximately 2 meters after leaving the launch tube, unlike the American 60mm rockets, which burned out completely inside the tube. This extended burn increased range and velocity, but created a massive backblast that posed serious danger to the operator and anyone standing nearby. Early test firings at Kummersdorf in March 1943 resulted in several injuries as operators discovered the weapon's backblast characteristics the hard way. The exhaust plume extended approximately 10 meters behind the weapon, hot enough to cause severe burns and temporary blindness. Operators needed to ensure clear space behind them before firing, and anyone within 30 meters of the backblast zone risked injury. This limitation would shape German tactical doctrine for the weapon's employment, requiring careful positioning and awareness of surrounding terrain and friendly troops. The German rocket ammunition itself already existed, which dramatically accelerated development. The Panzerschreck would fire the same Raketen-Panzer grenade 43-22 rounds designed for the Pupchen launcher. These rockets featured an 88mm shaped charge warhead containing 700 grams of explosive, more than triple the charge in American bazooka warheads. Penetration tests against captured Soviet tank armor demonstrated the round could defeat 160mm of steel at optimal impact angles, sufficient to threaten even heavy Soviet tanks from most aspects. Manufacturing preparations began even before the design was finalized. Germany's weapons production system, despite Allied bombing and resource shortages, retained impressive organizational capability. Heereswaffenamt identified 6 primary manufacturers who would receive contracts for the new weapon. These included Ensinger Union in Pfersheim, Harsag in Meuselwitz, Gebrüder Scheffler in Berlin, Jeckel in Fristadt, Kronprinz in Solingen, and Schürer in Fürth. Each facility would produce complete weapons or major components, with final assembly distributed across multiple locations to prevent Allied bombing raids from crippling the entire program. The weapon received its official designation in July 1943. The 8.8 cm Raketen Panzerbuchs, literally rocket tank rifle, soon shortened to RPsB. The designation would evolve to Raketen Panzerbuchse 43, commonly abbreviated RPsB 43, to distinguish it from later improved models. German troops would quickly adopt the nickname Panzerschreck, meaning tank terror or tank fright, a deliberate echo of the American bazooka name. Production planning documents from July 1943 reveal the scale of Germany's commitment. Initial production orders called for 382,000 units, an extraordinary number considering Germany was simultaneously manufacturing artillery, small arms, ammunition, and vehicles for multiple fronts. The plan assumed distributed manufacturing would allow sustained production even under Allied bombing, with component fabrication scattered across dozens of subcontractors and final assembly at the 6 primary facilities. The first production weapons left assembly lines in September 1943, just 10 months after the captured American bazookas arrived at Kummersdorf. This timeline represents remarkable speed in weapons development. For comparison, American development of the original M1 bazooka from initial concept to combat deployment had taken approximately 6 months. But that program started from a blank page with a revolutionary new concept. The German program had to reverse engineer a foreign weapon, scale it up significantly, redesign critical systems, and establish an entirely new production infrastructure. By September 8, 1943, Wehrmacht reports indicated the weapon would be sent to frontline troops for trials very soon. The official manual for the Raketen Panzerbuchs, a comprehensive document covering operation, maintenance, tactics, and safety procedures, was published on September 30th. The first major delivery occurred on October 5, 1943, when 1,500 weapons and 5,000 rockets reached combat units for field evaluation. The transformation from captured American weapon to German mass production had taken less than 11 months. The early production, Panzerschrecks, designated RPsB 43, measured 164 centimeters in length and weighed 9.25 kilograms empty. The launch tube was fabricated from seamless steel tubing with a wall thickness of just 2 millimeters, sufficient to contain the rocket's exhaust gases without excessive weight. Simple iron sights, a front post and rear aperture, were welded to the tube. The pistol grip contained the magneto generator and trigger mechanism. A wooden shoulder stock, simpler than the American bazooka's battery compartment design, provided stability during aiming. The production numbers that emerged over the following months revealed the true scale of Germany's commitment to the Panzerschreck program. Manufacturing records captured after the war show that between September 1943 and July 1944, German factories produced 289,151 RPZ-B-54 models, the improved version with a protective blast shield. This output occurred while Germany was simultaneously fighting on 3 major fronts, enduring increasingly heavy Allied bombing and facing chronic shortages of strategic materials. The economics of Panzerschreck production explained much of this commitment. Each weapon required just 10 work hours to manufacture at a cost of 70 Reichsmarks. To put this in perspective, the smallest traditional anti-tank gun in Wehrmacht service, the 3.7 cm Pak 35-36, cost 5,730 Reichsmarks and was largely ineffective against modern Allied tanks. A single Tiger tank cost 300,000 Reichsmarks. For the price of one Tiger, Germany could produce over 4,000 Panzerschrecks, each capable of destroying enemy armor that would take concentrated artillery fire to defeat through conventional means. This cost-effectiveness made the Panzerschreck attractive even as Germany's war economy contracted under Allied bombing and resource shortages. Manufacturing the weapon required no exotic materials or specialized machinery. The steel tubing came from existing hydraulic pipe production lines. The magneto-generators used components already manufactured for field telephones. The wooden shoulder stocks could be fabricated in small workshops using basic woodworking equipment. Even under increasingly dire industrial conditions, Germany could continue producing Panzerschrecks when more complex weapons became impossible to manufacture. The human cost of this production remains one of the darkest chapters in the weapon's history. HASAG, which became the third largest exploiter of forced labor in Nazi-controlled Europe, operated multiple production facilities using slave laborers from concentration camps and prisoners of war. By October 1943, over 60,000 workers labored for HASAG, more than half of them forced laborers working under conditions that can only be described as systematic murder through work. The company operated 165 prisoner labor subcamps by 1945. At HASAG facilities across occupied Poland, approximately 35,000 deaths occurred across various camps, though incomplete records prevent precise accounting of the full toll. Workers endured 12-hour shifts with exposure to toxic chemicals used in explosive manufacture, brutal beatings for minor infractions or perceived slowness, starvation rations calculated to provide barely enough calories to sustain work capacity, and virtually no sanitation or medical care. The Schlieffen camp, which produced munitions, including Panzerschreck components, housed between 2,000 and 5,000 female prisoners at various times. The average life expectancy for workers assigned to the explosive filling operations was approximately 2 months. An explosion at the facility on October 12, 1944, killed 96 prisoner laborers. German records classified this as a production incident with no investigation into safety conditions or causes. The dead were simply replaced with new prisoners from the camps. This brutal reality underlay the weapons' production numbers. Every Panzerschreck represented not just German engineering efficiency, but also the systematic exploitation of human beings, treated as disposable components in the Nazi war machine. The weapons that German infantry would use to defend the Reich were built by people whom that same Reich had marked for death. Combat deployment of the Panzerschreck began cautiously in autumn 1943 as initial production weapons reached frontline units. Wehrmacht doctrine called for careful evaluation of new weapons before widespread distribution, and the Panzerschreck's backblast characteristics raised legitimate safety concerns. Early after-action reports documented both impressive effectiveness against armor and sobering accounts of operator injuries from improper use. A November 1943 report from the 2nd Panzer Division on the Eastern Front described an engagement near Zhytomyr, where a Panzerschreck team destroyed 2 T-34 tanks at ranges of approximately 120 meters. The report noted that the shaped charge jets penetrated the T-34's side armor cleanly, causing catastrophic internal explosions. However, the same report documented 3 German soldiers suffering burns when they stood too close behind a firing Panzerschreck, unaware of the weapon's extensive backblast danger zone. By January 1944, Wehrmacht records showed 21,141 Panzerschrecks had been issued to combat units across all fronts. An additional 39,526 remained in armories, not due to lack of demand, but because of distribution problems in Germany's increasingly chaotic logistics system. German infantry commanders on every front were demanding the new weapon, recognizing its potential to address the growing armor imbalance as Soviet and American tank production overwhelmed German manufacturing capacity. Eastern Front forces received priority for Panzerschreck distribution throughout winter 1943 and spring 1944. Soviet armored operations during this period featured massive tank concentrations, sometimes hundreds of vehicles in coordinated assaults designed to overwhelm German defensive positions. Wehrmacht infantry, increasingly outnumbered and lacking adequate anti-tank gun support, needed portable weapons that could engage armor independently without waiting for specialized units to arrive. Soviet tank commanders began noticing tactical changes in German defensive positions by early 1944, where German infantry had previously relied primarily on magnetic mines requiring suicidal close approaches, anti-tank rifles that were ineffective against T-34 armor, and bundled stick grenades with minimal effect, they now possessed weapons that could engage tanks at ranges of 150 to 200 meters. Every German strongpoint potentially concealed multiple rocket launcher teams positioned to create interlocking fields of fire. The weapon proved particularly effective in defensive operations, where German forces could prepare positions that maximized the Panzerschreck's capabilities while minimizing its limitations. Tactical doctrine developed through combat experience called for teams to establish staggered firing positions no more than 115 meters apart, ensuring attacking armor-faced rockets from multiple directions simultaneously. Teams would dig shallow trenches or fighting positions that allowed clear forward fields of fire while providing sufficient depth for the backblast to vent safely behind the operator. Technical performance data from German and Finnish tests demonstrated the weapon's capabilities against various armor types. The RPZB Granate 4322 rocket achieved penetration of 160 mm of armor plate at 60-degree impact angle, or up to 230 mm at optimal 90-degree perpendicular angle. The rocket velocity of 110 meters per second exceeded the American Bazookas' 85 meters per second, providing better accuracy and shorter time to target. The 700-gram explosive charge, triple the American weapon's warhead, created devastating internal effects when penetration occurred. However, the effective range against moving targets remained limited to approximately 100 meters for most operators. Beyond this distance, the rocket's relatively low velocity and trajectory drop made hitting maneuvering vehicles increasingly difficult. Static targets or vehicles moving predictably could be engaged at greater distances, but combat conditions rarely offered such ideal opportunities. German training emphasized patience and fire discipline, instructing operators to wait for high-percentage shots rather than wasting ammunition on low-probability long-range attempts. The blast shield modification introduced in February 1944 created the RPZB-54 model, which became the standard production variant through July of that year. Early combat experience had demonstrated that even trained operators suffered frequent injuries from rocket backblast. The solution was a simple steel shield, roughly 40 centimeters square, mounted approximately at the tube's balance point. This shield protected the operator's face and upper body from the rocket exhaust, while adding relatively modest weight, increasing the weapon from 9.25 kilograms to 11 kilograms. Operators still required additional protective equipment, including heavy gloves to protect hands from hot metal surfaces during rapid firing sequences, and ideally some form of face protection such as a scarf or mask to prevent respiratory irritation from propellant gases. German field manuals specified that the backblast danger zone extended 10 to 30 meters behind the weapon depending on wind conditions and terrain. Anyone within this zone during firing risked serious burns or temporary blindness from exposure to the exhaust gases. Western Front deployment accelerated in preparation for the anticipated Allied invasion of France. By May 1944, German forces in Normandy had received thousands of Panzerschrecks distributed to infantry divisions expected to face the main invasion thrust. Wehrmacht defensive planning positioned rocket launcher teams to engage Allied landing craft and armoured vehicles at the waterline, where short ranges would favour the Panzerschreck's capabilities and the beach terrain would restrict Allied manoeuvre. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Normandy bocage country proved ideal terrain for Panzerschreck tactics. Ancient earthen walls, topped with dense hedgerows, divided the landscape into small fields, rarely larger than a few hundred meters across. German defenders used these natural barriers masterfully, positioning weapons teams in concealed positions where they could engage Allied armor at close range from protected positions. American tank crews advancing through narrow lanes between hedgerows faced the nightmare scenario of being ambushed at point-blank range, with limited ability to maneuver or return fire effectively. First Army after-action reports from July 1944 documented the Panzerschreck's impact on Allied armoured operations. The 2nd Armoured Division reported losing 47 Sherman tanks in the first week of bocage fighting, with post-battle analysis attributing roughly 30% of these losses to Panzerschreck strikes. Most engagements occurred at ranges under 100 meters, often with Allied crews never seeing the German teams that fired on them. The weapon's relatively quiet launch signature compared to anti-tank guns, just a sharp hiss and brief smoke trail, allowed teams to fire and relocate before Allied forces could respond effectively. American tank commanders quickly recognized their own invention, reversed and enlarged, being used against them. The psychological impact often exceeded the physical damage. Allied crews understood that every hedgerow, every farm building, every pile of rubble might conceal a Panzerschreck team. The weapon's distinctive launch left a bright flash followed by a visible smoke trail, and this signature became a dreaded sight for tankers who knew they had perhaps 2 seconds to react before the rocket arrived. German tactical innovations continued evolving based on combat experience. Successful teams learned to coordinate their attacks, with multiple operators firing simultaneously to overwhelm a target's defenses. They targeted specific vehicle vulnerabilities, including vision blocks that would blind the crew, engine compartments where penetration would cause fires, and track assemblies to immobilize vehicles for follow-up shots. Urban combat tactics exploited the weapon's capabilities while minimizing exposure to Allied return fire, using buildings and rubble for concealment, and firing from upper-story windows, where the backblast could vent safely behind the operator. International proliferation of the Panzerschreck began even before the war ended, demonstrating how Allied nations viewed the weapon's value. Finland purchased 1,854 launchers and 18,650 rockets for 200,000 Reichsmarks in 1944. Finnish forces achieved remarkable success against Soviet armor during the Continuation War, with post-war testing confirming the weapon could defeat 100 millimeters of face-hardened armor at 30-degree angles, sufficient to threaten most Soviet tank types from side aspects. Hungarian forces received Panzerschrecks for Operation Spring Awakening in March 1945, Germany's final major offensive of the war aimed at recapturing Hungarian oil fields from Soviet forces. The operation failed to achieve its objectives, but Hungarian after-action reports noted that Panzerschreck teams accounted for a disproportionate number of the Soviet tanks destroyed during the fighting, demonstrating the weapon's effectiveness even in the hands of Allied troops with limited training. Allied intelligence closely monitored the Panzerschreck phenomenon throughout 1944. A British intelligence report from January 1945 noted with concern that German production of nearly 300,000 units in 18 months exceeded total Allied bazooka production during the same period. American ordnance experts recognized that the Germans had systematically identified and corrected every significant weakness in the original M1 bazooka design, creating a weapon that was superior to the American original in virtually every performance metric except weight. The Americans themselves adopted German improvements for later bazooka models, demonstrating the circular nature of wartime weapons development. The M9 bazooka, introduced in October 1943, incorporated magneto-ignition nearly identical to the Panzerschreck system, eliminating the battery problems that had plagued earlier versions in cold weather. The M20 Super Bazooka, developed late in the war, but not seeing significant combat until Korea, increased caliber to 3.5 inches, directly following the German example of using larger warheads for improved penetration against increasingly heavy armor. Production statistics reveal the weapon's importance to German defensive strategy during the war's final year. Monthly production of the RPZB 54 model peaked at approximately 15,000 units in early 1944, before declining as Allied bombing intensified and raw material shortages worsened. By July 1944, when production of this model ceased to allow retooling for the improved RPZB 54/1 variant, total output had reached 289,151 weapons. Each weapon required components from 32 separate subcontractors, demonstrating the industrial complexity underlying what appeared to be a simple tube launcher. The improved RPZB 54/1 model, introduced in December 1944, addressed remaining deficiencies identified through combat experience. The most significant change was shortening the tube length from 164 centimeters to 135 centimeters, reducing weight and improving handling in confined spaces such as buildings or bunkers. Engineers also refined the rocket propellant formulation to reduce backblast intensity while maintaining velocity, and improved the optical sights for better target acquisition in low-light conditions. Despite orders for 48,000 of these improved weapons, only 25,744 were delivered before Germany's surrender in May 1945. The collapse of German industrial capacity under relentless Allied bombing made sustained production increasingly impossible. Engineers also developed experimental prototypes using impregnated cardboard tubes instead of steel to conserve critical materials, similar to designs being explored for the Panzerfaust single-shot weapon. These cardboard Panzerschrecks were tested at Kummersdorf in early 1945, but never reached production before the war ended. Ammunition production matched the scale of weapon manufacturing. German factories produced over 2 million rockets during the war, primarily the RPZB Granate 43, a 22 model, with its distinctive ogive shape and folding fin stabilization. Each rocket weighed 3.3 kilograms and came packaged in wooden crates of 2, with special markings indicating whether the propellant was formulated for winter or summer use. Temperature extremes affected propellant burn characteristics, and using winter-formulated rockets in summer heat could cause excessive chamber pressure and potential launcher damage. Transport frames allowed individual soldiers to carry 5 rockets in addition to their primary weapon and standard infantry equipment, though the combined weight of approximately 17 kilograms for rockets alone, plus the 11-kilogram launcher, meant Panzerschreck teams operated with significantly reduced mobility compared to regular infantry. German tactical doctrine called for positioning these teams in prepared defensive positions rather than expecting them to keep pace with mobile operations. The weapon's influence extended well beyond World War II, shaping anti-tank weapon development for decades. The Belgian company Mekar, which had produced Panzerschrecks under German occupation, developed the blindicide RL 83 inches the 1950s, using nearly identical operating principles. The Swiss Army adopted derivatives as the 8.3-centimeter rocket-propelled grenade, maintaining upgraded versions in active service through 1980. The Soviet Union, despite having captured thousands of Panzerschrecks, pursued a different development path with the RPG series, but these weapons shared the fundamental concept of an oversized shaped charge in a shoulder-fired reloadable launcher. Post-war analysis by American ordnance experts acknowledged German achievements while analyzing the factors that made rapid development possible. Colonel C.T. Richards wrote in a 1946 technical report that the Panzerschreck program represented history's most successful reverse engineering project, achieving mass production in under 7 months from initial captured weapon study. The Germans had taken a hastily developed American weapon and transformed it into a mature weapons system that exceeded the original in penetration, range, and reliability, all while fighting a losing multi-front war. Soviet forces captured thousands of Panzerschrecks during their advance into Germany from late 1944 through May 1945. Red Army technical evaluation teams noted the weapon's superiority to the American bazookas received through Lend-Lease, which the Soviets had initially rejected as insufficiently powerful for use against German armor. The Soviet Union had received only 3,000 American bazookas with minimal ammunition, finding them adequate for attacking light vehicles and fortifications, but marginal against tanks. The German Panzerschreck, with its larger warhead and greater penetration, better suited Soviet tactical requirements that emphasized overwhelming firepower. The last documented combat use of wartime production Panzerschrecks occurred during the 1948 Arab-Israeli War, when Syrian forces employed captured German weapons against Israeli armor. These Panzerschrecks had traveled through various conflicts and black market channels, demonstrating the durability of the basic design and the weapon's continued tactical relevance 3 years after German production ceased. Some examples reportedly remained in Third World arsenals into the 1960s, long after more advanced anti-tank weapons became available, testament to the fundamental soundness of the engineering. Technical documentation survived the war in remarkable detail, providing insights into German weapons development processes. The Wehrmacht's September 30th, 1943 manual provided comprehensive instructions for operation, maintenance, ammunition handling, and tactical employment. American intelligence translated captured manuals with an October 7, 1944 report detailing German firing procedures, aiming techniques, and safety requirements. These documents reveal the thoroughness of German training programs despite increasing wartime pressures and shrinking resources. Safety statistics highlight the weapon's inherent dangers beyond enemy action. German medical records indicate numerous operator casualties from backblast injuries, particularly among hastily trained troops who failed to ensure clear space behind their firing positions. Premature rocket detonations, though rare, occurred with sufficient frequency that German manuals emphasized careful inspection of each rocket before loading. Enemy return fire, attracted by the weapon's prominent launch signature, caused additional casualties, as Allied forces quickly learned to watch for the distinctive smoke trail and immediately target the firing position with artillery or small arms. Comparative analysis with contemporary weapons reveals the Panzerschreck's position in anti-tank weapon evolution. The British Piat, using a spring-launched spigot mortar principle, offered greater range but significantly less armour penetration and was notoriously difficult to cock, requiring the operator to use body weight to compress a powerful spring. The American Bazooka offered better portability and was lighter, but its inferior penetration became increasingly problematic as tank armour thickened throughout the war. The German Panzerfaust provided even simpler operation and lower cost per shot, but was single-use only, limiting tactical flexibility. The Panzerschreck balanced these competing factors, offering reusable capability with substantial hitting power. A trained two-man team could fire and reload in approximately 20 seconds under combat conditions, though this rate declined rapidly as operators tired from handling the heavy rockets. The weapon's effective employment required careful tactical planning to maximize its strengths while compensating for clear limitations, particularly the backblast issue that complicated use in confined spaces and the relatively short effective range that exposed teams to enemy return fire. Manufacturing quality varied significantly as the war progressed, and Germany's industrial situation deteriorated. Early production weapons from late 1943 featured excellent workmanship with precision-machined components and durable finishes. By late 1944, simplified production techniques and inferior substitute materials reduced quality noticeably. Captured examples from the war's final months show progressive degradation in finish and tolerances, though basic functionality generally remained adequate. Some late-war Panzerschrecks featured roughly welded joints, cruder wood for shoulder stocks, and simplified sights that were barely adequate compared to earlier models. The weapon system's complete infrastructure extended far beyond the launcher itself. Germany established Panzerschreck training schools at multiple locations, graduating thousands of operators monthly, even as the military situation became increasingly desperate. Specialized repair units maintained weapons at division level, replacing damaged components and ensuring electrical systems functioned properly. The logistical commitment matched that of traditional artillery systems in scope, demonstrating how seriously Wehrmacht commanders viewed the weapon's importance to defensive operations. Environmental limitations affected combat employment across different theaters. The weapon proved less effective in extreme cold, where propellant burned inconsistently and could produce insufficient thrust for proper stabilization. Desert conditions in North Africa caused problems with sand contamination of the magneto-generator's moving parts. Rain and moisture could cause electrical shorts in the ignition system if water penetrated the connections. Despite these limitations, the basic design proved remarkably robust, functioning adequately across diverse combat environments from Arctic Finland to Mediterranean Italy. Allied countermeasures evolved throughout 1944, as the Panzerschreck's tactical impact became clear. Tank crews began welding additional armor plates to vulnerable areas, hanging sandbags on hull sides, and installing wire mesh screens designed to prematurely detonate shaped charges before they reached the main armor. Infantry units adopted aggressive screening tactics, advancing ahead of armored vehicles to suppress suspected Panzerschreck positions before tanks moved forward. Artillery and mortars targeted any suspected firing positions with immediate heavy fire. Despite these countermeasures, the Panzerschreck remained a serious threat through the war's end, forcing Allied commanders to respect German defensive positions in ways that earlier German anti-tank capabilities had not required. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.